Hello, my name is Oscar and I'm a grade 9 student at King's. Today I'll be presenting to you my BaseF project. The goal of my project is to find out ways to stop the spread of the disease COVID-19. I got this idea for my project because what is happening around the world right now. No one likes being confined to their homes all day long. Many people have died. It's just a huge mess. It has affected me personally because of school. I don't learn well at all online. All the knowledge just leaves my head 5 minutes after class. This is all happening because of this disease. How can I fix it? I said to myself. The answer was to make a simulation application that could help me get data to find the most effective ways to prevent COVID-19 transmission. My hypothesis was when a certain amount of people wear masks or get vaccinated, transmission of COVID-19 will stop. I used Unreal Engine to code the simulation. In this simulation, people are represented by cubes. I programmed it so that the cubes move around randomly inside of the selected map. I made different kind of maps that have different kind of geometry, which alters where the cubes are able to move. Most importantly, all the maps I used for the data I collected are the maps default, an empty plane, park, which is pretty self-explanatory, and city, which is also pretty self-explanatory. One cube is infected from the beginning. This cube initiates the whole infection. How the simulation works is when the infected cube comes in contact with a healthy normal cube, it has a chance to infect the uninfected cube/person. Now the chance of this person getting infected varies very much depending if they have a mask, a vaccine, or both. How effective the mask and vaccines are is chosen in the menu before you start the simulation, as well as the percentage of people who have them. The simulation will now run. The user can now move the camera around freely after they leave the main menu, so they can get different angles on the simulation. The user can watch as the infection spreads across 100 people. The simulation ends when there are 0 infected people left. This can happen because after a certain amount of time, an infected cube will recover. So in theory, many outcomes can happen. 1. The infected cube never infects anyone. This is very rare, but has happened. 2. Everyone gets infected. This can happen, but it's still very rare. 3. Only some people get infected. Very probable this happened to me in most of the data that I collected. As well, part of my application is after all infected people are recovered, there is an after report screen that will give you all the data needed, including the duration of the simulation and how many people were infected in total. So I ran multiple simulations to see if the average number of infected people would go down when we increased the percentage of people with the vaccine. We went from 0% to 100% in 25% intervals, and I ran each simulation 3 times and averaged the number to get the 4 points you can see on the graph right now. The city gave some interesting results showing that random outcomes can happen, but overall in all the different maps there was a small decline the more vaccines we added, but not an insane drop. As well, when people were 100% vaccinated, the park had an interesting simulation where the infection died off fast, showing the vaccine can have an important effect. One way we thought we could get rid of outliers was just to see a more steady graph, was to use the median of the number instead of the average. And as you can see, it makes the graph a little more consistent, but still 100% vaccinated, we get a big drop off. Next, we look at how long the simulations have been lasting. We notice the more masks and vaccines we added on average, the time of the simulation increased. This is important because it shows us that the more people are vaccinated and wear masks, the more time the government and the longer hospitals have time to react. So last but not least, we configured the simulations so that 90% of the people had vaccines, but we increased the percentage of masks by 25% from 0 to 100. This graph has very nice decline and shows that wearing a mask and having the vaccine can be quite effective at stopping the infection. So from this data, we learned that wearing a mask and having the vaccine will either stop the infection or at least slow it down. But the only real way to stop it from spreading at all is to self-isolate, as shown in one of the city simulations where the infected cube went down a street with uninfected cubes and no one else got infected, and it ended very fast. So I came across a few difficulties throughout the programming process. One of them was when I loaded inside the map from the main menu, the AI or the cubes didn't want to move. Also, Changing the normal infected cube to the infected cube was a pretty big issue. The first problem with the AI not moving was solved by doing lots of internet digging. I poked around the Unreal Engine forums for help. In the end, it was just some little checkbox inside of the settings of Unreal Engine that I didn't have enabled. For the other one, I played around quite a bit with the code, and in the end, I ended deleting the uninfected cube, and then I spawned the infected cube with the coordinates and the exact rotation of the previous uninfected cube. Overall, the most fun part of the project was making the different environments/maps. The most educational part was learning how to make the AI. I'd used Unreal Engine a lot before for various personal fun projects, but I'd never played around with AI in Unreal Engine. This was the first time. But overall, the whole coding process was pretty fun. Doing the actual data part was less fun for me personally. This project was fully programmed and made in my room on the computer I'm using to record this. My mom helped me so much during this project, encouraging me, editing parts, helping all around. This project could not have happened without her. Of course, the BaseF Club staff at my school provided support and explained lots of things to me along the way as well. And if anyone's interested, I can give this project application to you. It's only for Windows though, not for Mac or Linux. To end off, I could continue the project by adapting it for other diseases. I wanted to add a probability for infected people to die once they got infected, but never got around to it. I could have tweaked around with some more settings as well, but the ones I use right now are pretty good. I could have optimized the sliders to make them more precise user-friendly. And yeah, that's it. Thank you for listening, and goodbye.